This video is going to cover the notes for Chapter 7, Section 1, which is angles of a polygon. Remember to take note while the video is going, and then make sure you submit them for the classwork grade for today. Like most of our chapters, this one starts with a lot of vocab. So we start with the parts of a polygon. Each segment that forms a polygon is called the side of the polygon. So the sides of polygons have to be segments, and obviously they're called the sides. The common endpoint of the two sides is called the vertex of the polygon. You'll have one vertex for each amount of sides. And a segment that contains any two non-consecutive vertices is called a diagonal. So where the red segments in this diagram are sides, the blue is where the vertex is. So D would be a vertex, B would be a vertex, A would be a vertex, and E would be a vertex. And then any segment that connects to non-consecutive, which means one not after the other, would be diagonals. So I could go from C to E, that would be a diagonal. From C to A, that would be a diagonal. Any of these, E to B would be a diagonal. A to D would be a diagonal. So any of them that are not next to each other. Some names of common polygons. So here's obviously 3 is triangle, 4 is quadrilateral, 5 is pentagon, 6 is hexagon, 7 is heptagon, and I would say those are the ones that people tend to confuse. So think 6 actually has the X in it, just like the word hexagon does. 7 is heptagon, 8 is octagon, like an octopus has 8 legs. 9 is nonagon. It kind of starts with spelling N-I-N instead of N-O-N, nonagon. 10 is a decagon. 12 is a dodecagon. There's no special name for 11, and any other sides would just be the number / gon. So 11 would actually be an 11-gon, 13 gon, and so on and so forth. It's obviously important that you know these because sometimes it will say find the number of sides that blank has, and it would be one of these names, and you'd have to know by recall that that's what the number of sides are. Okay, the sum of the interior angles. So obviously interior means inside. To find the sum of the interior angles of a convex, which means it's not caved in, you can draw all the diagonals from one vertex of the polygon, and it creates a set of triangles. And so the sum of the angles of all those triangles, which would be that 180, is going to be the sum of the angle measures of the polygon. So let's just say I had a hexagon, which had 6 sides. If I picked one of the vertices and I drew diagonals to each of the opposite sides, I'm making triangles, and there are 1, 2, 3, 4 triangles here. So it would be 4 times 180 to get the sum of the interior angles of a hexagon. But we're going to learn a formula that helps us remember that. This is just where that formula is derived. So if you were to go through just these 4 alone, triangle, quadrilateral, pentagon, and hexagon, if you connected the vertices to the opposite sides, there would be, obviously in a triangle, there's only 1 triangle. In a quadrilateral, there'd be 2. In a pentagon, there'd be 3. And notice the pattern is that it's 2 less than the number of sides. If you multiply that times 180, you get the sum of the interior angles, which is where that formula comes from. And that formula is this. The sum of the measures of the interior angles of a convex n-gon, so any number of sides, is 180 times n minus 2, where n is the number of sides. So if it had 5 sides, I'd do 5 minus 2, which is 3 times 180. If it was 10 sides, 10 minus 2, which is 8 times 180. That would give me the sum of the interior angles. And this theorem is really just a formula. The corollary, so remember a corollary is something easily determined from that. The corollary to theorem 7.1, which is the polygon interior angles theorem, says the sum of the measures of the interior angles of a specific polygon, which is the quadrilateral, is 360. So 4 sides, interior angles, 360. Definitions here: equilateral, equiangular, and regular. So hopefully we remember equilateral and equiangular from our triangles. Equilateral is all the sides are congruent. equiangular, all the angles are congruent, and new this round is regular. A regular polygon has all the sides and all the angles congruent. So it is both equiangular and equilateral. All right, example 1 says to classify the polygon by the number of sides and then tell whether the polygon is equilateral, equiangular, or regular, and explain your reasoning. So if we start with A, first of all, I'm going to count. This is 1, 2, 3, 4, 5, 6 sides, which means this is a hexagon. And then it has 1, 2, 3, 4, 5, 6 congruency marks, which means it's equilateral. It has 1, 2, 3, 4, 5, 6 angle congruency marks, so it's equiangular. And since it's both of those things, it is regular. And it has all congruent sides, all congruent angles. So that's the reasoning. If you go to B, you've got 4 sides, so it's a quadrilateral. You have 2 pairs, 1 tick mark, and 2 pairs 2, which means the sides are not all congruent. And the same is happening with the angles. One pair has 1 tick mark and the other has 2. So this is not equilateral, equiangular, or regular. So it would be none of those. And going to C, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides, which means this is a dodecagon. All the sides are marked as congruent, so it is equilateral. If you look at all the angles, the ones that are right angles, so obviously here and here, 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 and here are marked as congruent, but you'd have to have the same measurement at every vertex. So because this vertex and this vertex and this vertex and this vertex do not have the same angle measures, it is not equiangular, which means it's not regular. So it is just a dodecagon that is equilateral. All right, theorem 7.2 has a name, polygon exterior angles theorem. So we're talking about the angles on the outside now, and it says the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. So this one is not a formula. This one does not change no matter how many sides it has. If you take and add up all those exterior angles, it will always be 360 degrees. If you wanted to find each interior, first of all, it has to be of a regular polygon. This only works if they're all the same. Then I'm going to take the sum of my interior angle, which is the n minus 2, and times 180, and divide it by the number of sides. And it will give you each individual interior angle. Okay, so this one says find the sum of the A interior and B exterior angles. So we're going to start with a heptagon. A heptagon has 7 sides. So interior is 7 minus 2 times 180, or 5 times 180, and 180 times 5 is 900 degrees. And it wants sum, not each, so we don't have to divide that by 5 or by 7. And then B is the sum of the exterior, and that's 360 degrees, and it never changes. For 2, 17 would be 17 minus 2 times 180. So 15 times 180. 180 times 15. Bring down that 0. 2,700 degrees. And each exterior, so that's my interior sum, sorry, not each, sum of the exterior is 360 degrees. Example 3 says find the number of sides of a convex polygon with the sum of the measure of each of the interior angles equal to 900. So now we're going to go work backwards. So this is, we want to show the sum. So the sum would be n minus 2 times 180. And it equals 900 this time. And we want to solve for n. So we can divide both sides by 180. I'd get n minus 2. Well, I don't need the parentheses, sorry. N minus 2 equals 18 goes into 95 times, and then add the 2. So number of sides is 7. If it asked for the name of this polygon, it would be a heptagon. And example 4 says find the measure of each interior and each exterior. So now we're taking that sum and we're dividing it by n. So for a quadrilateral, first I'll do the interiors and then the exterior. So to find each interior, I'm going to do n minus 2 times 180 over n. And to find each exterior, it would be 360 over n. So a quadrilateral has 4 minus 2 times 180 over 4 would be 2 times 180, which is 360, divided by 4, and that's 90, which should make sense. A regular quadrilateral would be a rectangle or square. And then for the exterior, it would just be 360 divided by 4, which is also 90 degrees. So it's the only time it's going to be the same. A regular octagon would be 8. So 8 minus 2 times 180 over 8. I get 6 times 180 over 8. You can reduce this as you go, or you can multiply it and then divide it at the end. So it's up to you. Like I could literally say 3 goes in, or 2 goes in here 3 times and in here 4 times. And I can put the 4 into the 180, or I could have done the 8. It doesn't matter. So just making it a simpler, so this would be 45. And then 3 times 45 would be 135. So you'd get the same answer by doing 180 times 6. So 1080, and then 1080 divided by 8. So same answer, you get to choose how you do that. And then the exterior of a regular octagon would be 360 divided by 8. So 360 divided by 8. $45. And the last one, a regular 15gon. So it'd be 15 minus 2 times 180 over 15, 13 times 180 over 15. And I can, again, simplify that, like 15 goes into 180 12 times. And then I only have to do 12 times 13. And it's 156 degrees. Or I could have done 13 times 180, and you get 2340, and then divide that by 15. And you get the same 156. And exterior, 360 degrees divided by 15. So 360 divided by 15 is twice and 4 times. 24 degrees. All right, I added these examples on because you're going to see stuff like this in your homework. So if you want to take a quick screenshot or picture of the screen while these are up here. So the first one, you're going to get a couple like this where you get a diagram and it's going to ask you to find X, and it's either your interior or exterior. So these are interior. The first thing you have to do here is figure out what they should all add up to. So because it's 1, 2, 3, 4, 5 sides, I would do 5 minus 2 times 180, or 3 times 180, which is 540. So that's what they should all add up to. And then from that, I'm going to take away the ones I already know. So I've got a 90 and a 90. So I'm going to minus 90, minus 90, minus the 105, and minus the 80. And what's left, so if I did 540, minus 90, minus 90, minus 105, minus 80, what's left is 175. And that's what X would be. So when you're trying to find a missing angle from a diagram, again, figure out what the sum of the interior would be, which was n minus 2 times 180, and then subtract from it all that you have. If it gave you one, like you'll see one that maybe has all the exterior angles. So for these, let's say, I don't know, this is like 100, and this is like that. You would know already that they have to add up to 360. So you would do 360 minus the 100 minus the 60 minus the 90. And you get 110 for that last one. So this would be exteriors, this would be interiors. The other kind of question that you're going to see is each interior is given, and you have to find the number of sides. So if we work backwards from here, if I did each interior, then my equation is n minus 2 times 180 divided by n. And if that equals 135, and I want to solve for n, I'm going to go through this process. So if you just follow with me, if I wanted to find n, if I want to isolate n, there's two of them. So I first can distribute here. I'd get 180 times n minus 360 over n equals 135. I'd multiply both sides by n to get rid of the one that's in the denominator. I'd get 180 n minus 360 equals 135 n. And then I got to get both ends to the same side. So I'm going to subtract the 180. And I get negative 360 equals negative 45 n. And then divide both sides by negative 45. And n is 8. So this is if you're given the exterior. This is each exterior. And you're trying to find, and you're going to work backwards. So you're going to set your equation equal to what they give you, distribute the 180, multiply n on both sides, subtract the whatever that 180 n is, which is going to end up being negative, but the 360 is also negative. So when you divide, it goes back positive again. All right, so make sure you check the homework to see, well, first submit these notes. Do that now, and then you can start to work on the 7.1 homework. Look at the description of the homework for which ones you have to show work, because this time you're going to have to show a lot of work. Have a great day, guys.